Hi everyone and welcome back to Maths and Physics from Mr. Simons. Today's lesson we're looking at electricity and we're looking at the first of 5 variations. So what I mean with that is what's given to you to solve the problem, right? So this is from the November 2018 exam paper and all they've given us EMF, electromotive force and internal resistance. From there we have to determine voltage and unknown resistor R. Alright, so let's look at the question. So the battery in the circuit diagram below has an EMF of 12 volts and the internal resistor of 0.5 ohm. Resistor R has an unknown resistance, so we don't know R. Right, 8.1, what's the meaning of the following statement? The EMF of the battery is 12 volts. The reading of the ammeter is 2 amperes, so there the ammeter reads 2 amperes when switch S is open. Calculate the reading on the voltmeter, resistance of resistor R. Switch S is now closed. How does this change affect the reading on the voltmeter? Choose from increases, decreases, or remain the same. Explain the answer, right? So that's the questions. You can pause and attempt to answer as many as possible, but let's work through it together. All right, so let's look at the first question. 8.1, they want to know what's the meaning of the following statement. Now they say the EMF of the battery is 12 volts. Right, now this also appears in some multiple choice questions. Basically, we want you to understand that 12 volts is the amount of energy we give to a coulomb of charge, right? So when I say 12 volts, I mean 12 joules of energy is given to 1 coulomb of charge. So voltage can also be joules per coulomb, right? So EMF of battery 12 volts simply means the battery supplies 12 joules of energy per coulomb of charge. Right, so that in short is what it means. Let's look at the next question. They say the reading on the ammeter is 2 amperes, so there we have a 2 ampere reading when switch S is open. Alright, so if that switch is open, the 2 ohm is not partaking in the voltage and current that is moving through the circuit. So we're only working with R, and therefore there it's a series circuit, right? There's one part. They want the reading on the voltmeter, so there they've given me EMF. We need to know what's this voltage after we've lost voltage due to internal resistance. You see that 0.5 ohm in that box means there's an internal resistance of 0.5 amperes, not amperes, ohm. Right, so that's internal resistance. We have current for there, so I can multiply that 2 out to see how much voltage is lost there. And whatever is lost there means that is the voltage that is supplied to the rest of the circuit. So that would be the reading on voltmeter V. So first let's see what is lost. So V lost is my I total, meaning the total current, times the internal resistance, right? My total current is 2 amperes. You see they have highlighted in green. And R there is 0.5. So 1 mark for correct formula. Another mark for substitution. So there if I substitute, I have 2 times 0.5, right? And 2 times 0.5 or 2 times R would equal 1 volt. So all in all, I'm losing 1 volt, right? So if I lose 1 volt, V there in short should be 12 minus 1, which means then 11 volts, right? So my voltage external or voltage terminal equal my EMF minus V lost, right? EMF being 12 and my voltage loss being 1. So 12 minus 1, which then gives me 11 volts. Right? So all in all, the reading on the voltmeter is 11 volts. Right? We can also solve it differently. So I can use the EMF equation. Right? E equal to I, big R plus small r. Right? So there EMF equal I, R plus small r. EMF I know is 12 volts. I there is my total current, which is 2 amperes. R there is just this R. Remember, the 2 ohm is not part of the circuit. So I'm only working with this R here. Small r is internal resistance. We want to work out what is V external. Right, so 12 for EMF, current 2, R plus 0.5. So 12 divided by 2 would give me 6 equal R plus 0,5. So we want to divide by the 2. So 12 divided by 2 gives me 6, and I'm left with R plus 0,5. If I take plus 0,5 over, it becomes minus 0,5. So 6 minus 0,5, R then equal 5,5. And from there now, because I have R, remember, equation reads V equal to I times R. So I have the current, which is 2 amperes. I have the R here for this resistance. So 2 times that 5,5. V equal I times R. 2 times 5,5. Alright, because the 2 comes from ammeter reading there, and 5,5, and that gives me 11 volts. So my external voltage there is then 11 volts. So I hope you follow the process. So either one of the two if you want to go and solve. Right, let's look at the next problem. So they say calculate the resistance of resistor R. Remember now we have that the ammeter is 2 amperes. So there is 2 amperes and this voltmeter reads 11 volts. That's what we solved in the previous problem. Right, now this is when switch S is open. So all my external resistance comes from R. Internal resistance 0,5. External resistance comes purely from R. And we want the resistor of that R. So for the resistor R, I have voltage and I have current because it's in series. Remember, in series, current remains constant. Alright, so next, what's going on with you? Alright, external voltage equals my total current times my external resistance. So as I said, total current is 2 amperes. External resistance, what I'm looking for, external voltage 11. So I'm going to substitute 11 and 2. So I have 11 equal 2 R external. 11 divided by 2 and gives me R external equal 5,5 ohms. So this resistor here is 5,5 ohms. 1 mark for substitution, 1 mark for answer. All right. Let's look at the next question. All right, now they say switch S is now closed. So I close that. So as soon as I close that switch, I now have two resistors that are in parallel with each other. All right. So how does this change affect the reading on the voltmeter? Choose from increases, decreases, or remain the same, and explain your answer. So number 1, my voltmeter reading should decrease. All right. And the reason for it, as I add more resistors in parallel, all right, I reduce resistance effectively. So their resistance decreases. Right, resistance and current are inversely proportional, meaning a decrease in resistance will lead to an increase in current. Less resistance, more current can flow through. Right, so current increases. Right, and because current increases now, my loss voltage will also increase because I is bigger. So V loss there would increase. Therefore, my external voltage that's going out will decrease because I have a higher voltage, therefore, loss volt. So instead of having 1 volt, now I have, for example, 2 volts lost. So 12 minus 2 now gives me a smaller external voltage. So therefore, external voltage decreases, and my answer is decrease. Right, so I hope you follow, I hope you enjoy the lesson. I wish you nothing but the best. God bless. See you in the next one. Bye.